Okay, solving exponential equations. All right, so an exponential equation is an equation with variables that are in the exponent. Here are a few examples. You see where the variable is in the exponent of 2 and x plus 5 is in the exponent of the base 8. Okay, another example is 3 to the 2x is equal to 9. So how do we solve for those x's right here? Okay, so it says here to solve, you have to rewrite each side of the equation to the same base. That's the most important thing. If you were able to do this, then you can apply this method. Then you set the new exponents equal to each other after you've written them with the same basis. Okay, let's look at example 2 or exercise, right? Exercise 2. Okay, so our goal is to make sure that the right side would have a base 6. So are we able to do that? Well, let's find out if 216 can be written as a power of 6. Well, 216 is the same as 6 times 36, which is 6 times 6 times 6, which makes it 6 cubed. So here we see that 6 to the x is equal to 6 cubed. And when we've gotten the same base, that means we can really actually, like, we're dropping those bases. We're just setting the exponents equal to each other and just solving it. But here it's straightforward. So x is equal to 3. And that's your solution, because obviously if you plug in 3 into x, you get 6 cubed is 216. Okay, what about 5x? 5x equal to 0.04. So 0.04 has to be written in terms of the power or the base 5. So what is 0.04? Well, that's equal to 4 out of 100, isn't it? Okay, which is the same as 1 over what? 25, right? Okay, which is the same as what? We're going to write this. It's going to be 1 over 5 squared. We keep going, and that's going to be equal to 5 to the negative 2. Remember, if the exponents at the bottom, to put it up, you have a negative to the power negative 2. So here we have it, folks. You've got that part having the same base now. So let's rewrite everything. So what we've got is 5 to the x is equal to 5 to the negative 2. Therefore, we can drop those bases and say x is equal to negative 2. And sure enough, 5 to the negative 2 will give you 1 over 25, which is 0.04. So that's your solution. Let's look at the next example or exercise. Okay, here is a little bit trickier because, well, 9 is not really the base you want, or because 27 you can't write it in terms of the base 9. So what if we can break down 9 as another base? We can rewrite 9 as another base. So that gives us 9 is 3 squared, okay, which was raised to the x. And then what is 27 in terms of base 3? So that's 3 cubed, okay, and that was raised to the x plus 2 as its exponent. So remember the rule that if you have a power or an exponent raised to another exponent, you multiply them. So what you have here then becomes 3 to the 2x. And then here you have 3 to the what? Well, it's 3 multiplied to the x plus 2. So far you have 3 to the 2x is equal to 3 raised to, let's distribute 3 over this sum x plus 2. It's going to be 3x plus 6. So once we've already gotten here where you have the same base, all right, you can drop the bases and just set the exponents equal to each other. So let's continue. So what you've got so far will be 2x is equal to 3x plus 6. And if we solve for x, we just take off 3x from both sides. Okay, which means minus x is equal to 6. Multiplying both sides by negative, you say x is equal to negative 6. So that's your solution. And you can always go and check your answer. Plug it back into the equation. Okay? All right. Here we've got another problem where the base will be 7. So how do we write 1 over 49 to the base 7? Well, what's 1 over 49? 1 over 49 is 1 over 7 squared, which is 7 to the negative 2. So there you've got the same base. Okay, so far what we've got is 7 raised to the x squared plus 3x is equal to 7 to the minus 2. So there we've got the same base. So we drop those bases and just set the exponents equal to each other and solve that. Okay, so we've got x squared plus 3x is equal to minus 2. And this is just a regular quadratic equation. So we set it equal to 0, add 2 to both sides. You've got x squared plus 3x plus 2 is equal to 0. And we know that this is factorable because the factors of 2 are 1 and 2, and their factors add up to 3. So that's going to be x plus what? X plus 2 times x plus 1. So you're setting each factor to 0, you get x plus 2 is 0. So x is equal to negative 2. X plus 1 is 0, meaning x is equal to negative 1. So here your solution would be made up of two elements. One is negative 2, the other one is negative 1. All right? Okay, let's look at the next slide. All right, so you've got for exercise 6, you're asked to solve 9 to the x is equal to 3. Now, remember we set each side equal to the same basis. So our goal here now is to move 3 to the other side. So let's add 3 to both sides. Okay, so far we've got 9 to the x is equal to 3. Right, okay, so we need to make 9 as written in terms of the base 3. So that's going to be 3 squared to the x is equal to 3. So far we've got what? 3 to the 2x. Remember, because when you have exponents raised to another exponent, you multiply them. So that's 3 to the 2x is equal to 3. But what does that mean? What is the implicit exponent of 3 when it's just 3? It's 3 to the 1, right? So now you've attained your same base. So you just set the exponents equal to each other. So you've got 2x coming up here. You got 2x is equal to 1. Therefore, x is equal to 1/2. When you divide both sides by 2, you get x equal to 1/2. Which kind of makes sense because what is 9 to the 1/2? That's the square root of 9, which is 3. So 3 minus 3 equal to 0. So that indeed checks it out. All right. That's the last part of section 7.1.